not as a touch to the screen. That's why it made that right there. I actually thought that was something that symbolized recording, but it's not. It's just the color of the pen I was using last. There. So normally that's what it'll say. And if you'll notice, for some of you, if your English isn't your native language, it actually gives you a no, that's not the translation. It gives you a transcript, which you could then maybe translate later, the words.
Okay.
Or if you weren't sure how to spell a word, it's all over there. See everything that I'm saying? It's typing right now. If I keep going, it'll keep typing.
Hello.
You know what I'm gonna say? Talk to it. See if it picks you guys up. Let me say
Hello.
Oh yeah.
There you go.
It's a little slow, but it did eventually pick it up. So anyway, now back to an equation. So what's the definition we said of an equation? Super short, quick definition. It is.
How you solve the variables.
You don't have to actually solve it. It doesn't have to have variables. It actually doesn't even have to have variables in it, to tell you the truth. We're going to talk about that next class, probably, an equation that doesn't have variables.
But isn't it like solving the missing number?
Don't have to. Doesn't have to have a missing number. Doesn't have to have any variables.
Oh, wait, you solved the variable.
There's 2 words. It's just a rule. We said an equation is just a rule. And you have to follow that rule. And really, in all honesty, don't recall if I said this is part of that, because that's going to apply more to when we do word problems, which we'll get into probably not next class, but early next week. The rule is really always the same. It's that the left side of the equation has to equal the right side of the equation. So like if I write in, oh man, why does it keep doing that? It's reading my thing. If you don't touch it with a pen, like if I touch it with anything else, it'll read it as writing with a pen. Oh, I don't have to do it. I think this will fix that.
I think it does.
Yeah, there, now it won't do that. All right, so the rule is always this. So again, I think we did the same equation, but it doesn't really matter what the equation is. So if that's the equation, it doesn't matter how complex the equation is. There could be a million things on the left side, 1,000,002 things on the right side. Doesn't matter how complex it is. The equal sign separates the left and the right side, always. And we'll get into inequalities. If you don't remember what an inequality is, it's these symbols like less than, greater than, less than or equal to, greater. Those would separate the left and the right side once we get into those. We won't get into those for a little while. So now I have a left side and a right side to that equation. I didn't even really have to have an x there. I could have written a 3 there already and said 3 plus 4 equals 7. That's technically an equation. There's nothing to solve in that equation. We already have everything we need, but that'd still be an equation. The rule that this left side has to equal this right side, that's what allows us to solve. We didn't know that. If we didn't know that x plus 4 had to equal 7, we would have no idea what x is. No way to know what x is. But because we know this, whatever this winds up being, we're going to do a little activity, probably next class on that. Whatever that variable winds up being, when you add that variable to 4, it has to equal 7. Well, if it has to equal 7, we know it's that. So again, the rule behind an equation is the left side has to equal the right side. Here's another way that I want you to think of a rule. This is more of a visual way. Who knows what a scale is? What a scale is? What is it?
It's like the way like numbers go.
That is one type of scale. I'm talking about the more generic scale. It's not even really about math. What's that? No. More like a scale in a doctor's office or a scale in the public.
Like the one like that.
Yeah, one you weigh, right? That's what a scale is. You stand on it, knows how much you weigh. If you have like the balance type scales, have you ever gone on one of those and they have to move the little sliding bar thing back and forth and then they balance it to where it sits exactly even? That's more like the one I'm about to talk about. If you're weighing really small things, like not a person, but like a little tiny, like a penny or a quarter or something that small, there's a scale, and this is actually the way scales, I think, originated. I'm fantastic artist. Scale. There. So it's kind of like that. if it's in balance, then both sides are the exact same height. This side would be exactly even with that side, if it's in balance, which it should be in balance if nothing's on it. Now, I do a lot of fishing. So when I fish,
Oh, that makes me like you a little bit more.
you like to fish?
I like to fish.
Oh, I love to fish. I haven't been as much with the red tide. So if I want to fish, depending on what I'm fishing for, I need a certain type of, these are called lures, like they're not real, they're not like worms or shrimp. They're basically made of metal, yeah. So if I want a certain lure, I kind of need to know how heavy it is, because that determines how deep the lure is going to go, and that determines what kind of fish I'm going to catch. Sort of. So if I put that jig on that side, what's going to happen?
It's gonna go up. No, it's gonna go down.
That side's going to go down, the other side's going to go up, right? It's not in balance anymore. That scale that was in balance when there was nothing on either side, it's not in balance. It's out of balance. They're not even. What do I need to do to get it back to balance?
Add it.
You need to add one to the side.
I need to put, well, I need to do one of two things. I could actually take that off, right? And it'll go right back to where it was. I can subtract it off. But more likely, if I'm trying to weigh that thing, I need to put something on this side that is the exact same weight as that jig head. That's how weighing actually works. Even though you can't see it like underneath the scales and stuff, it's doing that same thing. It's taking whatever it's trying to weigh and it's adding weight until it evens out with the item. So let's say that weight that I add is 2 ounces. And now the other side goes up and they're exactly parallel. How much does that jig head weigh? Weighs 2 ounces. It's in balance now. This side is 2 ounces, even though it's in the form of a jig head. That jig head is 2 ounces. And then this is actually a weight that is 2 ounces. It's back in balance now. That's all an equation is. The equation is the left side has to stay in balance or has to equal the right side. If you can remember that kind of visual concept, and then the next thing I'm going to talk about, which is that thing at the bottom, you will find equations aren't that bad, even when the math gets pretty tough. Let's say I do this, Joe, just to kind of finish it off. Let's say I'm going to put a bunch of jigs in my tackle box. And so I put 2 more jigs on there to see how much they weigh and how much I'm adding to my tackle box. Well, if I do that, I need to balance it out, right? So I got to do 2 more jigs over here, or 2 more weights. And then let's say these 2 weights, because the jigs maybe were a little heavier. These 2 were 3 ounces each. Now it's back in balance. How much did just the 2 jig heads I just added weigh?
6 ounces.
They'd be 6 together, right? Because each of them apparently balanced out with one of the weights that's 3. So in total, they'd be 6. That's what you do when you solve an equation. You're just changing each side to make sure it stays in balance. Here, though, is the #1 rule. So this is one you write down. That was just more of a concept. You don't have to write concepts down when I say this is just a concept. This is what you need to write down. Make sure today is dated. Today's the 18th?
Yes.
18th, right? Today's the 18th, so make sure this is dated because you will find this. This I already know for a fact is on a quiz later in the year, but I probably will also move it and put it on one of the ones we do. Oh, you have an exit ticket on Friday, by the way, which is like a little quiz. So I don't know that this will be on there. Should be extremely simple. Some of the stuff though we won't even get to until Friday, but that's pretty easy stuff. So. All right, so Mr. Gill's most important thing when solving equations, that's what you need to write. And again, make it stand out, put exclamation points next to it, put a little circle around it, something, color it if you have highlighters or colored pencils. You're going to want to be able to find this one on today's date. Mr. Gill's most important thing when solving equations. No, I'm about to tell you what I believe. I mean, there's no, like, this is my opinion that it's the most important thing. Somebody else may say, no, that's not as important as this, but I think this is most important. Because the reason I think it's most important is if you always remember this, you actually can't do an equation wrong if you do the math right behind it. If you do the wrong thing, but you remember this rule, you'll still wind up getting the right answer eventually. It may take you a little longer. I'll give you an example of that probably in this class. So Mr. Gill's most important thing when solving equations. Remember, we have a left side and a right side in an equation. So keep that in mind when I'm about to say this. Whatever you do to one side of the equation, doesn't matter if you start on the left or if you start on the right. Whatever you do on one side, you've got to do that same thing on the other side. So for example, when I added 2 more jig heads to that left side, I had to add the same weight to the other side. That's doing the same thing.
That's what I know.
Yep. Whatever you do on one side of the equation, doesn't matter if you start on the left or start on the right. It depends on what the equation is like as to where you're going to start. Whatever you do on one side, you have to do the same thing to the other side. And I'll tell you why I emphasize this so much, because there's one mistake that I see over and over and over and over again that kills kids when they're doing equations, when we get into hard, more difficult equations. This rule will prevent you from making that mistake. And I see why they're doing it. Like, I see the logic behind it, and that's why so many people do it, is because it seems like it's the right step. Even after you look at it, it kind of seems like the right step. But if you remember this rule, you'll know it can't be the right step. I do. I'm older than I look.
How old you?
Oh, I'm gonna make a math problem with that one.
Okay.
I don't just give that out. You gotta work for it.
Okay. I'm going to do like 39.
55?
Maybe,
Oh.
maybe 70.
I think
I just told you I'm older than I look.
30.
I
Maybe.
think he's like,
I'll come up with math
Oh,
problem.
no, wait, because if you're actually 30, I'm going to feel bad because I just said you were 39.
Well, he said 55. If I was 30 and he said 55, he should
well,
feel
you
bad.
know.
All right, so if you remember, again, make sure, I don't only want you to highlight that and make it stand out. I don't just want you to do that because of tests. I mean, it truly will make solving equations a lot easier. Go ahead and put the headphones all the way away. And then I think maybe, yeah, you can try to cover that one up, but you can go ahead and put it away too, Henry. The long hair saves you, but you made a mistake and let your ears show for a second. So you can put it up too. It's harder to catch the girls doing it for sure, but every once in a while it's no problem. All right, so any questions on that? I'm going to give you an example of solving a really simple equation, which we'll get more into equations next. So if we have, again, I keep using this thing. All right, I'll change it up. There, I changed it up. New equation. So what's the answer? What is x? Pretty simple, right? X is 5. We don't need to do the math steps to solving it. But what you're really doing is you're saying, I need to get rid of that 5. Because I want x to be all by itself. That's what solving an equation is. You're just getting the variable to be all by itself. You're getting rid of all the numbers on the side where the variable is. Well, if I want to get rid of a positive 5, like if I've got 5 of something, to get rid of it, I take them away. I get rid of them. I subtract them away. Well, again, the rule is if I subtract them on one side, doesn't matter which side I start on, although you do have to learn how to figure out which side you need to start on, then you subtract it from the other side, and that's how you actually do the math steps.
And wait.
So, and we'll get into much, you'll never see an equation this easy on the test, by the way. I'm just giving you a basic.
So if there's more numbers, we obviously know that the one that like -5 I have to subtract to 10 because
Yep.
it's the only number that's there. But if there's more numbers that like we know that they're gonna be equal.
We'll get into that next class. We're not solving equations today. We're doing some other stuff. Next class we'll start solving equations.
My dad did the same exact when I was actually
Oh yeah. I mean, yeah, that's more of a middle school equation.
Without the line.
Yeah.
Without the line.
In high school, like I said, that's called a one-step equation because there's only one step. You just subtract the 5 and you're done. We will start at 2-step equations, which you've also done as well.
Yeah.
But you'll never see a one-step equation. High school math.
Most of it just shows.
All right, so now I'm going to show you that I can read minds. only about math stuff. Though. I can't read minds about other stuff. So yeah, you got stuff you don't want me to know. I can only read minds about math stuff. And I'm going to prove that with an activity that we're going to do. So here's what you need to do. Step 1, you need to write down a number. I don't care what number it is. Don't say it out loud because I'm going to read your mind. I would make it a smaller number, like, because you're going to do some math to it. No. So if you make it a bigger number, then you got to do more difficult math.
Like 1
well,
to like 50 or like 1 to 10?
I don't, don't tell me anything. I don't want to know anything about it. Make up a number, whatever you want, any number. Just remember, you've got to do math to it. So if you try to make it hard on me, you might initially be making it hard on yourself. I don't care. However difficult you want that number to be. So write down a number. Next, multiply that number. This is why I said you might want an easier number, because you're going to do some math. That way, you're even changing the number. So if I just read the number, you're changing it, so it's going to keep changing. It's going to make it harder. Multiply that number by 3. So you're going to change it again now after you do that. So you're going to keep changing on me, so it's going to be harder for me to read your mind. Now subtract 2 from that number. Whatever. So you do this, whatever you get to that number you just got, then subtract 2. Now you should be at a totally different number, obviously. So you should have your ending number, right?
Yeah.
Should be at a different number. Everybody good with that?
Yeah, I got it.
Okay, what's your answer for the ending number? Don't tell me the beginning number. What's your answer for the ending number? You got 15 for the ending number? I don't believe that's going to be correct. What do you got? Oh, you did go difficult on me, didn't you? So your beginning number was 69? Is that right? Man, red is mine. Oof, he was tough though. He made it harder on me. Boom. Who else wants me to read their mind? You want me to read your mind? All right, what's your ending number?
271.
Oh man, you're making it tough on me also, huh? 91.
I can't look at you.
What's that?
I read your mind? Did I get it?
Yes.
Bam. Mind reader. Oh, the ending number.
630.
Oh, you guys are making it. Wait. Check your math. 600 what?
33.
No, you subtracted 2? We'll come back to you. Just check your math again. Take that number, multiply by 3, and then subtract 2 again. Yes, sir. What's your ending number?
34.
Oh, boy, you made it easy. That is going to be 12. I read your mind. Yours was a little easier.
Oh!
34?
Oh, yeah.
Oh, yeah. Yeah. See, I read your mind even though you were thinking of the wrong number. It's 12. Your beginning number was 12, right?
Just
34.
Look.
Because 12 times 3 is 36. Subtract 2. So I'll let you in on a little secret.
I know it's multiple.
You know how to do math, though.
I want to do it.
You want to still do it? I'll still tell you. What's your ending number? That's how I know when some of you don't have the right number, is because there's no way I can get back to the original. You guys are making it so hard. Wait, somebody just had that number. Who else had 235? I could have sworn somebody had 235. No? All right, so 235 would be 79? 79. Did you change yours?
Yeah.
Did yours come out differently? Yeah, so you got, what's your ending number?
295.
I got one of that one.
295, you said? That would be 99.
Yes.
How am I doing that?
Okay, this is
Yes,
Magic.
more than
This is easy. This is easy.
It's like magic. What? Yeah, but what's math have to do with that?
Nothing.
Apparently it does, because I'll tell you right now, I'm not a mind reader. Did yours come out different?
Just by one number.
Yeah, so what? Whoa, just by one? What is it now?
634.
Okay.
Oh yeah, okay, that would work. So that would give me 212, I think. Look at you guys. I like that you guys all think hard. Every other class is thinking 1, 2, 3. Made it pretty easy on me. So, anybody want to know the secret so you can amaze your friends? We just created equations, is all we did when we did those steps. We started with your number, which I didn't know, right?
Yeah.
So what did I make that number when I created the equation? How did I represent that number in the equation?
You divided it.
I'm going to write the equation before I do any math to solve it. What did I use to represent your number? I'm going to give you a big hint in a second. Well, it's in the equation that I create. I'll give you a hint. Did I know your number?
No.
So it's an unknown number. So what did I use to represent an unknown number?
This one you might guess.
Who said it? I heard a few people. That's my variable. The variable is your number, your starting number, all right. That's the variable. I guarantee you go home and do this with some of your parents, they won't have any idea how you do it. Even if you do like the math and don't want to see the math, but even if you need to like try to fake it a little bit and act like you're reading their mind. So I started with your number, which I don't know, so that's my variable. All right, so I put that down. I don't know it. It's an X or a Y or a Z or a elephant or a zebra or whatever you want to make it. It doesn't have to even be a letter. Oh boy, good thing. See, good thing she had that cap. Can you reach it? What was the first thing you did to that number? Multiply, right? By what? So I knew you had to multiply it by 3. So in my head, I'm like, okay, I know they had to multiply by 3, but I don't do that part yet because you had to do something else. Oh, by the way, just as a reminder, this is not 3 and then times something coming up. This is 3 times the variable, 3 times x. Remember, a number next to a variable is 3 times that variable, whatever that number winds up being. So what's the next thing you did to that? Subtracted 2, right? So I knew you had to subtract 2. And then what did I ask you? This is the key part. Well, no, before I could give you your original number, I had to ask you what?
Last number.
What was your ending number? So I said, I think somebody said 295, right? That was yours?
Yes.
Yeah, you were one of the last ones.
Mine.
So once I knew, one of the rules about equations was if I have one variable and one equation, I can solve for that variable. And I do. One variable and one equation. So I can solve for that. And the way that I solve it is I start at the end. I don't start with what you did first. I start with what you did last. And this is really for 2-step equations. So normally there are other things you have to do to get it to this point. But I now undo or do the opposite of what you did in the opposite order. So I start with the 2 and I do the opposite. Well, if you subtracted 2, what's the opposite of subtracting 2? So I added 2. So I added 2 to that. So that gives me, this goes away. That's the whole reason I added the 2 was to get rid of it. I'm undoing it. This is why we do opposites when we solve an equation, because we're basically trying to undo what you did when you built the equation, or whoever built it and gave it to you. So now I have 297 equals 3x. What was our last step? Or our first step was multiplying by 3, so we need to do the opposite of multiplying by 3. So that's dividing. Again, quick review, if you ever see that line and there are numbers above it and below it, that line means divide. You won't see division written like, I shouldn't say you won't see it. Very rarely will you ever see that symbol in a math problem in algebra. Yeah, and sometimes you could see it like that, like in a fraction. Like sometimes a fraction 1/2 might look like that. Some worksheets, they'll do kind of the typewriter version and there'll be like a slash line. Those are both 1/2. It's just back in the day, this is more the way they would write fractions. Now, these days, they write them more like that. Same thing though, that line can be slanted sometimes. I'll typically write it more where it's like that. And then, so now in my head, I had to divide and say, well, 3 goes into 29 9 times, and then it goes into 27 9 times. That gave me the 99. That's how I did it. Didn't read your mind. Pretty cool. Sometimes I may not want to know what's. Oh, and this over here, the reason we also kind of divide by 3 is that gets rid of the 3. 3 divided by 3 is just 1. So the 1 just kind of, we don't need the 1. 1 times x is just x. So that's what I'll call sometimes canceling out. Anytime I make slashes like that, I'm saying those numbers canceled out. These went to 0 because 3x plus 0 is just 3x, so we don't need those anymore. This went to 1. 1 times x is just x, so we don't need the 1. So that's why we just have the x involved. But basically, you're doing the opposite math when you solve a 2-step equation, which is what we're going to spend a lot of time on next class. This whole, we'll do a worksheet where some of you can just get started if you really think you're remember some stuff about equations. I'll probably just give it to you and say, if you want to get started, get started. And then I'll do a lesson for those that need a refresher on it. So, we'll do that Friday. And your quiz, your exit ticket will be on that, as well as I'll probably give you 1 or 2 definitions, which you should just be able to look at. Any questions? Does somebody else want to try to do his? How about that? I think you can do it in your head.
Okay.
We'll try. All right, so tell Lee your final answer.
21, like 2,900.
Oh, you made it tough.
2,000.
But you got favor.
2,000 what?
2,908.
2,108. So here, we can all kind of do it.
Wait, 2,908?
100, I think, right?
No, 2,900.
Oh, it is 900. I'm sorry.
No, not 2,098. Sorry, 2,098.
90. Oh.
So say the numbers in order. 2098.
Yeah, 2,098.
There we go. 2098. So if everybody wants to try it, I'm not going to call on anybody, so it doesn't hurt you to try it. That's actually pretty easy.
Yeah.
Because it's going to come out to be a very round number after you add 2, which is very easily divisible by 3. That wasn't as bad as I thought it was when you started saying 1,000. Let us know when you have read his mind and you have his number. Or if anybody else is working on it, I'll come check it, or you can check with Alex. Dun, dun, dun. We're also going to do some name stuff today for some candy. Those of you who think you remember some names. Oh, I need to go through and see if I remember all of the names. I always get confused because I have 2 or 3 guys with almost the same name, but it's always different. But I do remember. Good. Oh boy. Yeah, I remember there was something about hair, but I still haven't figured out.
Yeah.
I can't see the clip. I can sort of tell it is in a clip now. And then I remember all of those. Ooh,
I got it.
what is it?
700.
No.
What is it?
I was going to like, what you said.
No.
No.
Because.
Wait, actually, I'm
said.
saying.
What's the first step though? But you have to start at the last thing he did. What was the last thing he did? So you add the 2 and you get this, right? You get that. Oh, I'm sorry. You're right. 2,100. You're right.
2,100.
You're right. I'm sorry. So yeah, that should be.
Go on.
And then you divided it by 3, you get 700.
700.
No, sorry, it's 700.
You gave us the wrong number.
Yeah.
I think you gave us wrong.
I gave
Supposed to be,
it, I got the
it's
right
supposed to be 2,998, which is actually what I was thinking. Well, yeah, he gave us that. He did some math wrong. Anyway, do that with your parents. See if they can figure out how you did it.
How did it?
No, do it with your parents. Like, have them pick a number and go through that and see if they can figure it out. I'll bet you there are definitely some that have no idea how you come up with it.
My crazy was good because she.
And then don't tell them how you did it.
My dad's an old school math, like the math major, so.
He probably will
He'll get it
understand.
done,
dad's
like,
one of
very
those.
fast. My
Yeah,
mom
we will
is a
understand.
little bit tricky on it, but knowing that my dad is, he'll get it done.
So remember, you need to help me police the room for activity that shouldn't be going on. Because there's some activity that shouldn't be going on. Because otherwise I wind up, instead of giving free time, we just do math.
I'm gonna do math anyway.
Well, yeah, if you want to do math.
Can I go to the bathroom? Can I do the math Friday?
Huh, apparently that person's not even listening.
They did math Friday.
What?
Math.
Math. Oh, early? No, we have other stuff we're doing today.
Oh, man.
We have other stuff we're doing today. Yeah, now's a pretty good break. So put your phone in there, then you take the pass.
What's it in there?
Let me see again. All right, so, and that was a while too, because I checked 2 or 3 times and you're still on. So, I think we're good there. Any questions on, like, again, that's more of kind of a conceptual thing. Just, I need you to understand when you solve equations, all you're doing really is you're going in reverse order and you're doing the opposite math to undo what they did to build the equation in the first place.
Yeah, in middle school, they
Created.
like the Common Core.
This is, well, Common Core actually technically went away, but it's basically the same thing as Common Core.
Kinda.
We haven't really gotten to standards yet. We're still doing review stuff. Well, I take it back. Solving equations is a standard that you have to know as a high school student. So, all right, one more thing. I'm going to actually add a slide. I haven't done that for other classes, but I'll add a slide. So here's the other review thing that you need to make sure you remember for algebra. This again, every year, this kills students that just can't get this concept down. So this year, I'm actually going to do a little activity next class about this, but I'm going to review it first, then we'll come back to it then. You need to know what like terms are.
Like fraction?
No. I mean, they could, fractions are like terms with other numbers, but there's way more to it than just.
Like common numbers.
I would know, I like that.
It has to do with what you can combine and what you
Exactly.
can't combine.
Oh, that.
Some things you can combine and make them just like 2 terms. You can combine them and make them 1. Some you can't. And it's critical that you know which ones you can and you can't, or else you won't even be able to solve the simplest of them. So if I write down, oh, I didn't even go over what an expression is. I'm also doing what an expression is right here as well. So let's say I have this. We'll say 6 plus 2x subtract 3 plus x. What's that I just wrote up there? That's 6 plus 2x subtract 3 plus x. What would you call that thing? That is an expression. Yeah, I just said we're wrong. Why isn't it an equation? It's got numbers and variables and math operations. Because what? I mean, no, that's not why. You can have that.
Oh.
You could have that in an equation.
Like,
We'll go over what that means. I'm going to give you some definitions.
I think it's because this step is like a order to do it, like a step.
No, there's an order to do equations too.
No.
Well, let me ask you this. Oh, no, not yet. Somebody else had a hand up before I go on. No, you can have that still in an equation. I'll give you a hint. It's not because of what's there. It's because of what's not there. Bravo.
The answer.
There is no equal sign. There's no equal sign, and there's nothing on the other side of the equal sign if it was there.
Oh.
We cannot solve that because we don't know what's there. We don't have a left and a right side. We don't have anything to balance it out with. So you can't solve an expression. You cannot come up with the value of x from this expression because we don't have anything to compare it with to say, oh yeah, I can use that to figure out what x is. All we can do with an expression is what's called simplify. So I'm going to write the word expression since it was on the other screen. All you can do with an expression is you can simplify it. What does that word simplify mean? Either in English or in math. What's that mean?
To make it simple, to make it short.
What's that mean? Give me a better, you can't use the same word to define
To make
it.
it smaller, to make it like a smaller.
Smaller is pretty good. I like smaller. There's another word I would sort of use because it's not always
Think of it
smaller.
like a fraction.
Yes, you simplify fractions. So when we simplify fractions, what are we doing? We are kind of making them
Make it
smaller,
like a
but
mixed number.
could be a mixed number. Doesn't have to be though.
Expect with an end number.
Smaller is not bad at all, because even if we simplify a fraction, the numbers will get smaller when we simplify them. If we simplify an expression, we would have fewer terms in the expression. Well, here, right? Easier is the word I would use. It just looks easier. It looks a little simpler. It looks a little easier. So easier is the way I think of simplifying. Smaller works too, though. I'm never going to ask you the definition of this, by the way. So what we're going to do is we're going to take this thing that has 4 terms in it, and I'll come back to what a term is, and we're going to make it a smaller, easier, simpler looking expression. It'll still be an expression, but it'll just be a little bit easier looking expression. First thing you need to know, how can I describe that? There's only one way to describe it, and that's every term, but I'm trying to think of another way to describe what a term is. You understand? A term could be made up of a lot of things. It could be just a number. It could be a number and a variable, or it could be 2 variables. It could be like X and Y next to each other. That would be a term. The key is they're separated by some kind of a addition. They're separated by either addition or subtraction, not by multiplication. This is multiplication, but that doesn't make those 2 individual things a term. That's all one term. This is a term here. I'm going to do it a little differently in this class. Technically, I should really circle the negative sign. It's really -3 plus -3, but I'm just going to circle the 3. And then this is also a term. So that's what a term is. The things that are separated by the addition and subtraction. So we have 4 terms. What you need to really understand is what like terms are, because those are the only ones you can combine. You can add or subtract to shorten up or make the expression smaller. Any idea what the like term is with the number 6?
Oh,
the 3?
and 4 and 2 are not good.
Is it the 2?
Because no, you can do 3, 4, or no, is it 4?
2, it's 2,
Just
3,
listen, you guys have
4. Is
to-
it all of it? 1, 2, 3, and 4.
They're not all like terms. They're all terms.
Yeah.
They're not all like terms.
Just 6 and 3.
Yeah, it's just the numbers. And when I say numbers, I'm about to give you a couple definitions that you do need to know. Again, I won't quiz you on these, but you will become completely lost if you don't understand what these are, because I'm going to use these words all the time when we're doing equations. If you have a term that is just a number, there's no variable here, right? There's no variable in that with that 6. There's no variable with that 3. Here, I'm just going to give you the definitions down low, and I'll come back up to the. This is the definition of a constant. It's just a number. Like no variable with it, just a number. No, just 6 is a constant. Number. I'll write, this isn't great English, but this is math, not English.
But we speak English.
True. Actually, a lot of the stuff they give us is. If you struggle in English and reading comprehension, a lot of times the math stuff you see on tests is difficult because they're making a lot of word problems and a lot of, like I said, they're moving toward more understanding and explaining than just here's a problem. What's the answer?
Yeah.
So a constant is a number not with a variable. Like there's not a variable next to it. Like up here, again, 6 doesn't have a variable with it. And next to variable doesn't mean like next to this variable. Remember, each term, once you get to the plus sign, you're on a new term. So I'm on a new term. I'm on a new term. So if a term isn't being multiplied by a variable, then it's a constant. Now here's your other definition. They're kind of similar, so that's why I'm going over it and reviewing it, because again, this is stuff that I'll bet a lot of your teachers have probably never reviewed, and you learned it a long, long time ago, 6th or 7th grade.
Yeah.
A coefficient is also a number. Yeah, we'll just say number for now. That's a number with the variable, or a variable. That's the word variable. I'm not going to go back and change it because it's written right above. So the number that is with a variable is the coefficient. So 2 is a coefficient because it's with that x. it's being multiplied is what I should technically write. If I'm multiplying a number times a variable, then that number is a coefficient. What's the coefficient on x? Is there one?
What?
The x, the last x. What's the coefficient on that? It is a 1. There's a coefficient there. We don't see a coefficient, but technically there is a 1 in front of every variable, if it doesn't already have it.
Yeah.
The reason we don't need it is because 1 times x is just x. So why would we write the 1? It doesn't change anything. So if you don't see, it's also all right, I'll come back to that. All right, so anyway, constant and coefficient. I'm going to say those a lot through the rest of this class, and then moving forward, probably every day we do equations, because every equation pretty much has a constant and a coefficient, sometimes multiple constants. Constants can always be combined. If you just have a number, like no variable with it, you can always combine those, add them together, subtract them, whatever the math is you need to do. So we can combine that 6 and that 3. These are like terms. Oh, I got to give you the definition of like terms. So here's your definition of like terms. Kind of 2 things. I'm going to make it 3, but it's really just 2. So number 1, they have the same letter. Technically, I should say same variable, but since we pretty much are going to see variables as letters from now on, I'm going to say letter. You might want to write, I'll write same letter and then in parentheses, same variable maybe. But it's same thing. Same letter, same thing. So that's the first thing like terms have in common. The second thing is, and this is the one that trips people up, they have the same exponent. What's an exponent? Raise your hand if you remember the word even exponent, but you don't know what it is at least. Or if you know what it is, that's fine too. Raise your hand if you, like, yeah, and I remember what it is. I remember the word and I remember what it is. If you do.
I remember the word, but not the name.
It's hard to explain, even if you kind of could do it yourself. It's still hard to explain. I'll show you. Oh, I can write it up there. I'll change colors so it doesn't get too confusing. I have that, right? What does that mean?
Oh, now.
3 times 3. This is not 3 times 2.
No, it's 3 times.
That is 3 times 3.
You could have done like, not like that, but.
I'm going to give you a different example in a second too and ask you what that would be. So we don't just take the exponent and multiply. So this is the exponent up here. That's an exponent. It's the same thing as the power. Exponent and power are the same thing. That's a power of 2, or it's the exponent 2. This is the base. You don't ever just, and I mean never. There is never a situation ever where you will multiply an exponent times its base. Never. It's just not the math you do. The exponent is telling you how many times you need to multiply this number times itself. So 3 squared equals 9, because you multiply 3 times 3, just twice. If that was a 4 instead of a 2, it'd be 3 times 3 times 3 times 3. So you'd have to keep multiplying. 9 times 3 is 27. 27 times 3 is 81. So 3 raised to the 4th power, or 3 with an exponent of 4, would be 81, because you keep multiplying 3 times 3 times 3 times 3. So when I say same exponent, oh, and then I guess I'll write this last thing. I'm going to be saying this a lot too, but I'll still write it down. You can combine like terms. They're actually the only things you can combine. If they're not like terms, you cannot combine them. So like terms are the only things in an equation or an expression that you can combine. And we're going to do next class, the activity will revolve around variable, what a variable is and like terms. So today I'm just going to kind of go. All right, so when we come back up here, a lot of times I'm going to get rid of stuff that I've written.
I have a question.
Yeah. Oh, that's fantastic lead into what we're about to do right now. I'm going to go over a couple of things on that. So I will a lot of times erase stuff that's up there that I've written. So make sure you don't lose focus and miss stuff and, you know, try to come back and catch up because it won't be there a lot of times. Let me do this real quick and then I'll start that. I think we have somebody waiting, right? Didn't somebody ask for bathroom? Oh, you did? Oh, okay. Oh, I said it was a good time to go earlier. Yeah, let me just finish this up then. All right, so we have like terms. What did we say the first two like terms were? I think Dakota maybe said it. Somebody else said it. 6 and 3, they are. But here's the tricky part. Somebody just asked it. If you didn't know what Leah was asking, I think it was Leah. You were asking. She said, wait a minute though, when I go to combine those, am I combining 6 with a -3 or am I just combining 6 with a +3? Good question.
Depending on the case,
I'm not going to go into a long explanation right here, but I'll tell you right now, on my YouTube, I do little videos on stuff that I just don't have time to do in class because it's not like a 9th grade standard. It's an older standard and I can't go back and review every standard. I've got one called adding, combining, something like that, positive and negative numbers, which is what I'm about to do. So I'm not going to go into a lot of depth here. But if you really want to understand that, because it'll save you a lot of time, because there is a section of the EOC next year where you don't get a calculator. You won't be able to just do that in a calculator. There's a whole day where you do not have a calculator. You got to know how to do the math and get or on paper.
My teacher said last year when we did like terms that whatever the bigger number you were combining with, like if it had a sign or not, that would be the sign.
And that's what I go over in my video. The way I explain that is with like a visual thing, but that is correct. So the first thing you need to know, if you don't already know this, make sure you write it down. So Kira, hopefully you're listening. Again, I don't wake people up nonstop throughout a lesson. If it becomes an issue, we'll talk about it, but some days I know you're tired. You can always go back and watch the videos too if that was one of those tired days. The sign in front of a number is the sign you use. I don't think of this as 6 plus 3. I need to think of it as 6 subtract 3, or better is 6 plus -3. Really, if I did teach 7th grade and I did teach it this way, I would never ever tell anybody that subtraction exists. I wouldn't even let you know that there's any such math operation as subtraction. I would say you are always adding a negative, because that is just much cleaner and it's a lot easier to understand, especially when you're dealing with a negative and a negative. That really throws kids off. But if you would have been taught that way from the beginning, and I don't remember in my video if I actually teach it that way or if I teach it another way, but if you could somehow kind of retrain yourself to understand, this is actually a 6 plus a -3, that there's no such thing as subtraction. The sign always goes with the number behind it, and that's just going to be a -3, and you're going to be adding -3 with the 6. It makes this kind of math with positive and negative integers a lot easier. So what it would be is if we said 6 subtract 3, or if we thought of it as 6 plus -3, both answers are the same. And I'll do a quick, I may or may not do this on the video. Let me ask a question, raise your hand if you play football, or you understand. Tell you what, raise your hand if you understand board game. Make it even, hopefully just about everybody's done a board game. If I am on, kind of works better for, doesn't even really matter. Although it's better, I'm going to do a makeup game because then you're going to draw a card. So let's say you are on spot 6. Right, so you're on spot 6. Space 6, all the numbers, or they just go in order from 1 up. And you draw a card, and it says, oh boy, I'm going to go to football. Football's easier for this one. So let's say you're on the goal line. Or no, we'll still say 6-yard line. That's fine. 6-yard line's still fine. Raise your hand if you know American football real quick, because I don't want this to be like, you don't have to know it great. It's not a super complex analogy. So in American football, real quick, you can get penalties. A penalty is like you do something wrong and they give you a penalty and you have to go backwards. You can also go backwards because you run a play and you get the other team like tackles you or knocks you backwards, we'll say, for those of you who really don't understand. So there's two ways to go backwards, penalty and then. So now, let's say you're on the 6-yard line. I'm still going to use 3, even though this isn't realistic for football. And let's say you do the penalty first. You commit, I guess, a penalty. Commit a penalty. You're given a penalty. So let's say you're given a penalty, and the ref throws the flag, and the ref says, well, I have a whistle. You are getting a penalty of 3 yards. They give you, so they're giving, that's addition. You're giving somebody something, that's addition, but it's a penalty. So it's a -3. They give you a 3-yard penalty, so you go backwards. Where would you be? You'd be the 3-yard line now, right? Okay, another analogy. You're on the 6-yard line. You run a play now. You're running a play from this line up here, but you go backwards with the ball, and then you get tackled 3 yards back. They just subtracted 3 yards from you. You just subtracted 3 yards from where you were. Where are you at?
3.
Same thing. Adding a negative is the exact same thing as subtracting the positive version. So that bottom one is actually subtract +3. So when kids ask me this question, I never know how to answer it. Is that a -3 or is that subtract 3? Well, it depends. It's really both. Again, I do a whole video on that, so I'm going to go ahead and stop there. So so we got this part. So when we combine those, oh man, I got a little tiny. So we get 6 subtract 3 is 3. Now, do we have any more like terms? Not with the 6 and the 3. Those are the only two that are just numbers. Oh, said. So we have a 2x. What do we need to ask ourselves to see if that's a like term with the other term that's left? What did I say the two things were? Yeah. No, it doesn't matter if it has a coefficient, because we're just trying to tell first, is it a like term? You just wrote it down. Look at your notes. What determines if it's a like term? Two things. Do we have the same letter, we said, or a variable? Is the same letter in those two terms?
Yes.
Yeah, x, right? Do we have the same exponent in those two terms?
Yeah.
Ooh, it gets a little quieter when I ask about the exponent.
Wait, no.
Somebody said no, somebody said yeah.
Well, wait.
How do you determine that? Do you see an exponent? So what's the exponent?
2. Oh, no.
Here's a 2. It would tell you it's a 2 because we just put a 2 on the, remember 3 squared earlier.
Wait.
So is there an exponent? What is the exponent? Like, how do I know if it's the same exponent?
It isn't.
X is not its own exponent. It's not x to the x.
It isn't, because that's negative.
That's a great point. Determining whether or not terms are like terms has nothing to do with the number in front. You don't look at that at all. That does not matter at all. And it has nothing to do with the sign in front. All it has to do with is just the variable and just the exponent. So just the letter and just the exponent. Let me ask you this. What is the exponent here on this x? See if anybody really remembers their math from 7th and 8th grade. What? Look at Dakota on fire today. I don't see an exponent here, but there is one. There's an exponent on every variable or number. There's actually an exponent of 1 on all of those. And there's an exponent of 1 on the 2. Every number, every variable has an exponent. If we're not showing it, it's an exponent of 1. It's kind of the same reason we don't show this one right here. 6 to the first power is just 6. It doesn't change anything, so we don't write the 1 in. That would just be extra work for no reason. If the exponent doesn't change the math we're doing, if it doesn't change the value of that number, then we're not going to write it in. We're just going to write 6. Technically, though, there is a 1 there and a 1 there. So I'll ask you again. We have the same letter, x and x. Do we have the same exponent?
Yes.
Yeah.
Yes, we do. Those are like terms. So we can combine those. What's the answer when we combine them? What do we get? 3x. We have 2. Oh, I didn't do this one thing. 2x is literally this. It's x plus x. That's what 2x means. X is obviously just x, right? How many x's do you have?
X equals X, there you go.
You have 3 x's, right? That's, I told you before, think of variables as physical things, because they are. You have 2 of them there, 1 of them there, so you have 3 of them. If this would have been a subtraction sign, you would have said, well, if I have 2 of them there, and I'm taking away 1 of them, how many do I have left? I would have, well, I'd have 1. If I had 2 and I took away 1. So again, if you think of variables as physical things, that works. Or think of them as money. If I have $2 here, I got another $1 over there that I'm adding, I got $3. We're going to do a little thing on Friday that kind of is an example of that. And hopefully that will help you have a visual in it, because 2 or 3 of the biggest problems students have all year long is everything we just went over today. Like terms, well, and the other thing. What is a variable? And then that mistake I said, where they don't do the same thing on both sides when they're solving. They either do it twice on one side, or they forget to do it on one side. If you can remember all these basic things that really you probably didn't go over a whole lot since the first time you actually learned it, you just kind of, they just said, okay, do this, and then there's your answer. Hey, super simple. But then you don't remember it, you don't understand.
So, wait, if we write not the variables, the exponents in, do we get credit?
No, but I will tell you, when we get to a lesson on exponents, I'm going to tell you to write them in every single time, because if you don't write them in, you're going to forget to use them, and you do have to use them in the lesson we do on exponents, which is that's like next semester. All right, so we are done. I'm going to stop the recording. Say bye.
Bye.
Bye. That's a commercial, I think. Bye. And what we're going to do now is you guys for the most part have been good about the phones. I did have 1 or 2 people I had to say something about, but then they didn't try to get back on it that I noticed. I wasn't really looking as much as I do some days. So I'll let you do phones, but I'm also going to do some name stuff for Candy. So, and you can do both, like if you're on your phone and then you want to do that as well, I'll call on you. Yes, ma'am. Oh, and then yeah, next for the bathroom. You can, actually you don't even have to leave your phone now because we're allowed to be on phones. So.
I don't. I have my phone in the bag.
So let me, as soon as I get done with shutting the recording off.
I can go, right?
Yeah.
Okay.
I will start the name game stuff. Fabulous cash and prizes. Stop recording. All right, so that's done. I'll probably post that, not that you really need a whole lot to go back and look at that, but again, those are the things that wind up keeping a lot of people from not doing very well on the equations part of the class, which will last for probably 3 or 4 weeks. Yeah, maybe 2 or 3 weeks. So I guess I can close that out now. I don't need to use it again. I'll also do attendance real quick. If you want to have a snack or have something to drink, I'm fine with you doing that now, and I can kind of make sure that you're careful about it and that there's no trash and stuff on the floor. So if you haven't had anything to eat or drink this morning, now's a good time. Why is that not working? Go.